Hello, everyone. I'm Xiaogang. Okay, we missed something in this lesson, right? So at this point, this part is equivalent to refreshing subtasks. So how do we refresh subtasks? Actually, it's a matter of a variable loop. Then, I'll write this function out here. It should actually be written in our periodic method, because here we can actually do an incremental query. The simplest way is an incremental query. Actually, a lot of the time, when we use the UI. Wait, but writing it this way, is it correct? It's not wrong, because doing incremental queries on the client side is a very normal operation. Sometimes we continuously monitor health. These operations are all very normal. Then here we update our subtask status. Let's first create this implementation. Its function is actually to iterate through our list of managed tasks. That's it. And actually, this part can actually be optimized. You'll notice that we can actually use this tmap. In the managed task, we can store in this task, we can store a managed task ID. Then we directly pull the managed task ID to copy and modify it. This way, it's actually more convenient. But it should be fine. I think. Yeah, actually doing it this way should be fine too. Let's just use a for loop. As I just mentioned, I think using a loop sometimes is actually more straightforward, and that's fine. Let's just use a loop directly. Okay, let's use this here. Then, let me think about it for a moment. I think we shouldn't use a loop. Using a loop feels a bit low level. Let's store an ID here. This ID is called belong to managing. Task it. And this ID, we need to initialize it as empty. It cannot be empty. If it is empty, then there must be a serious bug causing the problem. Then I can use something like an assertion. So actually, when we work on this part, we must attach this child. You see, I created it. And don't mix up these half IDs. Its manage belong to. Which task does it belong to? It obviously belongs to this ID. See? For this ID, and then OK. It belongs to this ID. So that means this task of mine, it is recording. It recorded the ID of this managed task. So we might need to pass this task one more time here. Think about it, then just test it one more time. Let's back it up once. It should be fine. This part is designed a bit convoluted. This ID shouldn't have any naming conflicts. Here we'll make a value copy of it. Here, we'll also make a value copy of it. Then here, we'll also pass it in. Okay, then here, we need to change the function signature. Yes. Then here we change it to managed task ID. Then here we change it to manage task ID. Let's get a bit more information. Okay, then here we don't need to do the reverse operation. We can directly use this container. Because we made it into a tmap, then we can use a find function. The find function, we pass in this key. After we pass in this key, you can see. Then it will return a pointer to a pointer, I think. It will return this pointer. Actually, the type it returns as this. Then, if we give it a name here, we call it manage_task_py. Yes, it is a type like this, a bit strange. It is a bit strange. It is a pointer pointing to a smart pointer. Such a type. Then this pointer should be, let's name it ptr. Otherwise, people might get confused. Then we only proceed if this pointer is found. We will only do it then. Yes, it must be found. If it is not found, there might be some issues. It might not exist. Improper removal. So here we give it a check. Okay, then check false. It will assert it. After finding it, we need to access its contents. It will have a teddy inside. Here, it seems we can only iterate, and this part is relatively simple. Then we iterate. For iteration, let's use A2. Like this, edu_kmp. Just run it. Here it should be ManaDesk. It will have an array inside. Here we need to take a reference. We have to dereference it once. After dereferencing, we get this pointer. Then after this pointer, we access the task inside it. Okay, alright. After updating the state like this, we check, that is this PMG task. If its ID, it is a smart pointer, its ID. Is it equal to our ID? Right. If they are equal, then we just update its state. Then we directly copy this state, copy this information. If they are equal here, then we update this enumeration. This enumeration, we need to work on this layout. Let's change the name. Then, based on success and failure, and then return this information to this place. Okay, so this actually refreshes our task status. Then what do we need to do next? Is when the number of refreshed statuses, if all have been refreshed, then we need to trigger our callback delegate. And here we actually have some business to handle. Let's just use tick for it. After the status has been updated here, I will need to iterate through all the granny tasks, all the subtasks within it, all tasks, whether they are all completed. So actually in your case, you can obtain this management task. Then in your case, you can check the status of this management task. If, for example, this is the method, it is this method, this status. If this status is already successful, then you need to trigger this callback. Where is this callback bound? It is bound here when we declare this task framework, the bound callback. There shouldn't be any problem, right? So this places A1. That is A1 enters here. Then after updating ABC, check task A. If task A has not yet completed all 10 tasks are not yet finished, it waits for the next task to update and come back into events. If task A has already completed all 10 tasks, then we will use this function method to determine whether it succeeds or fails, or continues to wait. Then if it succeeds, execute. Success or failure, execute this agent. If continue waiting, we wait for the next subtask to arrive. Okay. We won't write it this complicated. We'll write it in the tick because this management task, after we finish executing, we want it to be able to be removed normally. Then let's first take a look how this thing should be triggered. It starts first and then ends. When it is triggered, how does it determine the state? Then this state, actually it is determined like this. That is to say let's first take this message. Let's first assume it is successful. This message, we consider this to be successful, right? And then here we have a need. This determination requirement, we create a break loop. Break loop, we iterate through our current list. The current list, as for the current list, then we check the status of each task. Whether each task status has failed. If there is a failure, this task has a failure condition. We consider it failed, then find this enum. Consider this task as failed, then we may need to copy this information again. As for this information, we essentially, I think we shouldn't write it this way here. We give an empty child. We take this many information. we splice it on. How do we splice it? Actually, just write it like this. Okay, good. This part is essentially splicing the task ID into the manage-task information. Then, regarding the specific reason for the failure, incorporate this information into it. Then we directly change our task to this failed task because one of his tasks has failed. If it fails, we will directly return a failure here. There is an extra one written here. The current task status is this. You can just directly return this. Then we continue to determine the status. Then if it has this task status, it proves that it is in a state like low. It proves that it is actually still in the process of being handled. We consider it to be returning the processing status. If all the previous steps have been completed, this proves. What is the proof? It proves that our task was successful. Then we just need to piece together this information. This proves that this information, it is for this subtask. It is successful. Yes. We paste this information in. Okay. So this is a method of checking. Good. So every time a subtask comes in, it will determine whether the current was it in such a state before. Then we take its subsequent execution. Whether to execute this agent, we still put it into the ticket to do it. You can put it here, but I think if it's placed here, it's a bit convoluted. This is just a method to determine all current tasks, whether it's only all tasks, only if all are this. That is, if there is one that fails, or if all are successes, right? Only then will it yield a success or fail status. Otherwise, it is always in the possession state. Possession state, we do not process it, only the states that return success or fail. We will process though. Okay. Then there might be a situation here. That is my task. Number 5 fails. My tasks 1, 3, 5, 8, 9, 0 are all successful. In this case, the information for 8, 9, 0 might be missing because task number 5 might be executed at this point. It means that when it executes task number 5, it actually already skipped it. Correct. So, to avoid having failed tasks, we directly skip this. So we still hope that, let's take a look. Then we'll take this triangle. We won't return here. We'll return here. Just return this directly. That is, if it has this low-end state, it means this task is not completed. Then this place will return processing. As long as all its tasks are either success or failure, then all success or failure information will be recorded in. So it will wait until all information has been executed. Only then will it return for the next step of processing. This logic is fine. This logic would be better. The previous one we had would be a bit faster because it can detect failure at the first moment. It might then cancel the other tasks. But the way we're writing it now is that it requires all 10 tasks to have all information recorded in place. Okay, now let's do some work in the tick. Okay, it seems the subsystem of ours doesn't support tick yet, right? So let's add the tick functionality to it. We can just paste it from here. Then we paste from here. Okay. Okay. Alright, after we do this, let's implement this tick. Okay, we can just read this over here. For this tick, actually, this CDO here, let's paste it over. We don't want it to perform a CDO operation in this tick. For this ticket, we'll use this one. Then we put this lane name here. Then we execute the logic inside this tick. Then you can call a super tick. But actually, it doesn't seem necessary because calling super tick probably won't work. Maybe we saw it before. We saw that it's a virtual function. Okay, so what do we do inside the tick? First, we prepare an array. We'll use this array later. This is our already all fetish manage. Anaji tasked. Okay. Not all completed. First of all, we might need to iterate. We have a for loop. Iterate through all our current tasks. How to iterate it? Actually, we covered this in chapter 3 or chapter 4 earlier. Sometimes we talked about how to iterate this kind of tmap. Actually, you can write tpair. Here we will directly use O2. This is the most convenient. Manage. Tmap manage. Let's add a pair for it. This way, we can see it more clearly. Then first, let's make a simple judgment. That is, if this Kamiki pair, its values task number, is not equal to its current value, then task number task. Yes, that is, if its current quantities are not equal, this is task. It should be like this. No problem. What are these two things? One is this task number, one is this. Their quantities are equal, because there might be cases where some of our tasks are added dynamically. You know what I mean? It is added dynamically. So this part must be equal. Only then can we prove that all characters have been declared. Only then will we proceed. If they are not equal, we will let it continue. We will skip it. Skip the current managed task. For example, if B is not ready yet, we will skip B. Let's go check CDE. Is it possible there are other managed tasks? Then here we retrieve it. Let's take a look at our current one. This check status state. We retrieve this managed and the current state. Then here we need to use it. Just stick to the correct state. If its state is success or failure, then we need to add this ID into it. See? Because if it's success or failure, it means it has already been completed. Right. Then we take this Felish magic text ID and add it in. Let's record this. We'll need it later because we are still in the loop. This ID should be its K value. Okay, let's record it like this. All the A tasks we need to process, B tasks or C tasks. So how do we handle them? First, it's quite simple. We'll just iterate through the loop. Tipu manage task IT. Then this loop. Just loop through this number. Then we retrieve it. We definitely have it this way. We can directly use the correct construction method to retrieve it. Okay, as for the type here, it is, let me check. When we click over here, it is this. The type should be this type. Then we retrieve this task, and then we pass this in here. This is retrieving it, right? Then we need to check. Not finished. This is the task. The result of B many tasks. Task RESU, and it is equal to the state we can currently access. We can access it once more. That's no problem. Because it has already been completed, its state will no longer change. So we can directly access it like this again. Whether it equals this succeed. If it equals succeed, it means this animal succeeded. If it does not equal, it means it failed. Well, here we can take a look. This ternary operator here should be a question mark. Here is a colon, goes. Okay, let's stretch it a bit longer to show everyone. This right side needs to be closed. I don't know why there is an extra one of these. Maybe this wasn't noticed either. Okay, so this part has been executed successfully. Then we have finished executing. We don't actually care whether it succeeded or not, because the one that cares is this delegate. This delegate is the one that will handle the result. It just needs to broadcast here. Broadcast. Then we put this information in. This result. Then we read this information again here. Okay, then the delegate here will trigger the callback we bound earlier. After this is done, we are about to start resource recycling. How do we recycle resources at this point? That's very simple. You can just use a simple loop to remove them. We still iterate through this ID, manage tasked. Then we get this host. Then we can directly remove it, because it is a smart pointer. We don't hold smart pointers elsewhere either. This essentially takes care of all management tasks and subtasks from the root. Then let's compile this. See if there are any errors. Okay. There is an error here because we didn't capture this class pointer. Because this is a member method. What does it say here? This method can verbal reserve lambda properly because the causing not allow impacts. This method might not be easy to implement because we didn't capture it here. So this kind of captcha actually has risks. You can write a static method, as I emphasized. This kind of capture actually has risks. Okay, so now we are basically done. Now we define it as successful, right? Now let's execute it. Not easy. We'll execute it in the next lesson. Next lesson we will get this completed framework. Let everyone execute the test.